So we're going to do the calculation on the worked example on the page, calculation of the coefficient of friction. We're going to do the worked example. So it starts off with a diagram, and they say a body of metal is on a surface. So sometimes it helps to draw yourself a little diagram. And they say it has a mass of 20 kilograms. And they also say it takes a force of 49 newtons that way to keep this thing moving at a steady space across an even surface. So they won't complicate the question. They'll always give you keep the body moving at a steady pace across an even surface. So they're telling us it's 49 newtons. But like we sort of said to you, they won't always give you the units of measurement in things that you want. Now the newtons here is fine for calculations, but here he's given me the mass of the metal, but he hasn't told me the weight of it. So how do we find the weight of anything? Well, the weight of anything is equal to its mass multiplied by that little dot there, or an x if you want. Its mass multiplied by the acceleration produced by gravity. Now that's a standard value. We'll discuss that elsewhere. So the g thing is a standard value, so that's equal to the mass we're given, 20, multiplied by the acceleration produced by gravity is 9.81, and you just multiply those two in your calculator and you come up with an answer of 196.2 newtons. So there's your answer. So from being given the mass here, I now know the downward force is 196.2 newtons. Now I'm going to let the calculator worry about all these oddball figures. I'm not going to get worried about them. So like we explained earlier, the symbol for the coefficient of friction is that mu. So mu is equal to the horizontal force divided by the downward force. So the horizontal force, the one that acts along the horizontal, is 49, divided by the downward force. Well, we were given the mass and we worked out the force here. The downward, or the downward force, sorry, is 196.2. So all you do is just punch into your calculator 49 divided by 196.2. Now because that's a small number and that's a big number, you know your answer is not going to be a full number. It's not going to be a whole number. It's going to be something less than 1. And when you do the division there, you get an answer of 0.25. Now because it's just a ratio between two sets of forces, there's no units of measurement involved. If you look at it, this here is 49 newtons and that there is 196 newtons. Newtons above the line cancels with newtons below the line, so there's no newtons in your answer. So it's just a ratio. Now if you're doing any of these problems, normally the coefficient of friction for friction materials is in around 0.3. So if you're getting an answer of 5.6 or something like that, you know you're going wrong. Your answer should be around 0.25, 0.3, 0.35. So that's your worked example.